Assalamualaikum students, Adil sir here welcoming you to our unit of calculus, and we are discussing the unit integration. Today our topic is definite integrals. We have already discussed several things that are present in this unit. First of all, we discussed what are primitives and what is this indefinite integral, and we know that the solution of indefinite integral is not unique because of the fact that indefinite integral is actually the family of primitives, and we know that what is primitive if we have a function f of x, and if the derivative of this f of x we have a function f of equals to small f of x, then we say the primitive of this f of x is f of x, and we know that this primitive is not unique for a function. And when we define the indefinite integral of f of x, we say it is the family of primitives, and we write it as f of x. If d by dx of f of x is equal to f, we write it f of x plus c, where this c is only added because of the fact that it gives us infinite solution of this f of x, and by this c we are saying that the indefinite integral is not unique, a unique value. So now we are about to define this definite integral, and definite integral is the integral having now unique solution, having now unique value. And the notion of this definite integral is beta. If we have a function f of x such that the derivative of capital F of x is equal to this f of x, this one, and if this f of x is continuous in a to b, we know that the function is actually the curve. If this curve is continuous in a to b, after this, if this is our curve f of x, and if it is continuous from this a to b, then the definite integral is denoted by the definite integral of this f of x is denoted by a to b f of x dx. It is the notion of this definite integral of this function f of x, and this a or this, it is called a lower limit, and this b is called upper limit. This b is called upper limit. Just we know that the indefinite integral have a lot of methods to get found. The first method that we were applying there was inspection method, and then the second one was this substitution method. Third one was this integration by parts, and the fourth one we discussed in our previous lecture, that was converting a function into fractional fraction, so partial fraction. So now we will write the notion of this definite integral. What is that, beta? A to b f of x dx. We write here if, or you write down, let f of x be a continuous function in continuous function 1, this closed interval of a to b, then definite integral of fx is denoted by a to b f of x, denoted by this a to b f of x, where a and b are called lower and upper limits respectively. What that mean? That means this a is the lower limit and b is the lower limit of this integral. So this is our notion of this definite integral. while finding the indefinite integral, we had lot of methods, substitution method, this integral, so on method, so on beta. Now, for finding this definite integral, we have also lot of methods. The two methods we are going to show here are, first one is definite integral as a limit of sum. Definite integral as a limit of sum, and its statement is, if we have function f of x that is defined on this AB and is continuous here, then this definite integral of f of x dx, it is equal to limit as tends to 0 h summation r is equal to 1 to n f of a plus rh. This is our first formula, and the second one we can write it as limit as tends to 0 h summation r is equal to 0 to n f of a plus n minus 1 a plus rh, where nh is equal to this b minus a. This b minus a is equal to nh, and we will prove these two formulas in our next lecture. And the second method is that we have to apply here, that is better like this. Second method. First method is definite integral as a limit of sum, and second method is like let f of x be the primitive. Let f of x be the primitive of this f of x. Then integral of a to b f of x dx is equal to this definite integral of this function. If this capital F of x is the primitive of this function f of x, then definite integral of this f of x a to b dx is equal to f of b, capital F of b minus f of a. This formula is called the fundamental theorem of integral calculus. Second fundamental theorem of integral calculus, that gives us the definite integral of f of x dx is equal to f of b minus f of a. And in your syllabus there is only statement. Proof you have to get in further classes. So here you need to memorize this, that is a to b f of x dx is equal to f of b minus f of a. Now beta, we will try to find out some examples so that we can get it properly. But if we have a function f of x that is equal to sine of x. Now we have to find out this 1 to 2 f of x dx. So 1 to 2 f of x dx, it is equal to, we have to first find out the primitive of this function, and in that primitive, if that is if we get that f of x, and in that primitive we have to put this b and a, we have to put these 2 and 1. So that is 1 to 2, that is 1 to 2. 1 to 2, we know the primitive of this f of x, or the integral of this f of x, is equal to sin x, that is sin x, and its integral will be cos x but minus cos x, and then we have 1 to 2. What is that equal to beta? That is equal to minus cos of x minus cos of x, but we have to apply these values. Cos of x, that is cos of 2 minus cos of 1. This is our answer, beta. Similarly, if you have a function of like this, is equal to x cube, and you have to find out the 1 divided by 9 f of x d. How you can find out it, beta? You have to find out like this: 1 divided 9 f of x, that is x cube d x, and that will be equal to, you have to find out the indefinite integral of this, and then you have to put the values 9 and 1, or you have to find out the primitive of this. What is the primitive of this? That is beta x4 divided by 4. We know that x cube plus 1, this is our formula, and we know that that is x cube 4, and then we have to put 1 divided by 1 to 4 the value. When we will put here 4, it will be first 1 divided by 4, and then it will be x4 power 4 minus this, then it will be 1, x cube 1, and then 4. This is our answer to this integral. So similarly, you can solve all the integrals. This is very easy, and the most important thing that we have from this definite integral, that is this definite integral, if we will define it, is actually the area under the curve enclosed by the bonds x is equal to a, x is equal to b, and by x axis. This definite integral, if we have a function f of if we have y is equal to f of x, and if this is our y axis and this is our x axis, this is our bond x is equal to a, and this is x is equal to b. The area under this curve y is equal to f of x, that is this, and the area which is enclosed by this x is equal to b and x is equal to a, that is here, and the x axis, that is this. This area is equal to definite integral of y, this f of x d x. So we can say that the definite integral of a function is actually the area enclosed by that function, and the bonds x is equal to a and x is equal to b, and the x axis. This is our geometrical interpretation of this. We are going to prove it in another lecture, that will be confined one, that will be whose statement will be now this area theorem. We will call this beta area, and we will prove it also, how it is the how this definite integral is actually the area under this y is equal to f of x and this bond is. We will prove it. This is our first geometrical interpretation of this, and now we are going to solve some examples with the help of this fundamental theorem. If we have this, you write down the example first. 0 to 3 x plus 4 dx. You have to find this definite integral. How you can find beta? First you will find out the indefinite integral of this x plus 4, or you will find out the primitive of this x plus 4. Then you can apply these bounds. So when I am going to find the primitive of this, the primitive of this x is x square divided by 2, plus this primitive of this 4 is 4x. Then we will apply these values 0 to 3. What that says, this is our, for example, f of x, and the definite integral says beta f of x, this definite integral that you have to put these bounds in this f of x, that is f of b minus f of a. This integral is equal to now f of b minus f of a, while this f of x is this. So you will get here f of b, that is b is 3, so here it will be 3 square divided by 2 plus 4 into 3, and then minus this 0, that is 0 square divided by 2 plus 4 into 0. It will come out at 339 divided by 2 plus 4 312. This is our answer. Similarly, you can find other integrals, other definite integrals that will also follow the same rule. Now, today, as you know that I have already told you, I have some work, so our lecture will be very brief today and very short. The next, I am going to have for you an assignment, that is, first one you have to find out the integral, that is a to x is 3 to 4. This cos x plus tan x dx, and then you have to find out this 9 or minus 1 to plus 1 x raised to power 5 plus root of x dx. These integrals you have to solve by yourself, and we will now stop here. Tomorrow our lecture will be on basis of this area theorem, and the second one will be how we can find this integral with the help of this limit of sum. We will show you, we will find out the formulas that I have already given you. This limit as tends to 0 and so on. This h summation of, we will try to prove them, and this is all today's lecture.